Everyone's familiar with the narrative that a colossal rock from outer space collided with Earth millions of years ago, resulting in the demise of the dinosaurs. Thanks to advanced technology, researchers have pieced together a fresh timeline, shedding light on the catastrophic events. Moreover, they claim to have identified the potential source of the enormous asteroid. Is Earth at risk of another colossal cosmic impact, and could humanity endure such an event? Prepare to be astonished and perhaps dismayed by the recent revelations from NASA astronomers. The impact of the giant asteroid in the shallow waters of the Gulf of Mexico 65 million years ago was devastating. Subsequent calamities ensued, including rocks falling from the sky, wildfires igniting, and tsunamis inundating distant coastlines. The researchers, armed with high-resolution photography, microscopy, computed tomography imaging, and magnetic measurements, compiled a detailed record of the chaos that unfolded on the first day of the Cenozoic, as documented in the Proceedings of the National Academy of Sciences. Picture yourself in North America approximately 65 million years ago, amidst a world ruled by dinosaurs, gazing at the night sky. What you might have initially perceived as a distant bright star would evolve into a colossal asteroid, ranging between 11 to 80 kilometers wide, 7 to 50 miles, hurtling directly towards Earth at a speed of 72,420 kilometers per hour. As the hours passed, the asteroid, on a direct course for the Yucatan Peninsula, pierced through Earth's atmosphere like a boulder into a puddle. Unlike smaller meteors that decelerate rapidly and burn away in the upper atmosphere, this mountain-sized Chicxulub asteroid maintained its velocity, plunging through the entire 60 miles of atmosphere in just 3 seconds. The asteroid screamed over Central America, unleashing a deafening sonic boom that reverberated across continents, likely instilling terror in the dinosaurs. Unaware of the impending catastrophe, these creatures likely scattered in all directions. However, any animal close enough to witness the asteroid would have been instantaneously vaporized within minutes. With the exception of sea turtles and crocodiles, no four-legged animal larger than 25 kilograms would likely have survived. The rapid descent of the mountain-sized space rock prevented the air from escaping, resulting in intense compression. The compressed, superheated air reached temperatures in the thousands of degrees almost instantaneously. Even before the asteroid made contact, the compressed and superheated air vaporized much of the shallow sea covering the Yucatan. In the milliseconds following the impact, the colossal rock smashes through the remnants and collides with the bedrock, setting off a chain reaction of cataclysmic events. The tremendous pressure exerted by the asteroid transformed soil and rock into flowing fluids, reminiscent of the double splash effect seen when someone does a cannonball in a swimming pool. The initial outward splash, created by the asteroid's impact, reaches over 32 kilometers in height, 20 miles. The impact nearly breaches Earth's mantle, and the subsequent rebound forms a delayed vertical splash, propelling the Earth to heights exceeding Mount Everest at over 1,600 kilometers per hour, 1,000 miles per hour. Within minutes, the mountain of debris collapses, resulting in a series of secondary explosions and leaving behind a smaller mound known as a crater's peak ring. Simultaneously, the kinetic energy of the 7.5 billion-ton rock, hurtling at 16 kilometers per second, 10 miles per second, transforms into searing heat in an instant. The Chicxulub impactor delivers an astonishing amount of energy, surpassing 1 septillion, 300 sextillion kilojoules, 1 septillion 300 sextillion, more than 1 billion Hiroshima atomic bombs. The transferred kinetic energy excites molecules to temperatures hotter than the sun's surface, ionizing the air and forming an expanding fireball of plasma exceeding 10,000 degrees. The rapid expansion of heated air, coupled with the near-instantaneous conversion of Earth into gas, generates a massive blast wave of pressure expanding outward at over 1,600 kilometers per hour. If a similar asteroid hit today, the blast wave would vaporize individuals in Texas, deafen those in New York, and shatter glass windows in Buenos Aires. The Chicxulub impactor resonates with Earth like a bell, triggering waves in the Earth's crust radiating away from the impact zone at 4 kilometers per second. These waves induce fault-slipping earthquakes across continents, with the ground shaking felt 30 minutes after impact on the other side of the world. The impact instigates tsunamis towering as high as skyscrapers, striking Gulf coastlines within the hour. Waves ranging from 600 feet to possibly 1,000 feet flood tens of miles inland, temporarily reversing the flow of rivers and rushing up riverbeds like 30-foot tidal bores. Tsunamis reach the eastern coast of the United States, maxing out at 600-foot high walls of water that crash into Europe, Africa, and the Mediterranean coasts 6 hours after impact. Within 15 hours of impact, waves reach every coastline on the planet, sweeping away anything in their path and receding to the sea. As if this weren't catastrophic enough, the impact splash ejects 25 trillion tons of Earth, launching debris on ballistic trajectories. Some rocks exceed Earth's escape velocity, orbiting the Sun, and a portion of the material likely reaches the Moon. However, the majority of ejected debris returns to Earth within the hour. These glass-like tektites, ranging from the size of buses to marbles, rain down at lethal speeds between 160 to 320 kilometers per hour, creating a fiery hailstorm that pummels the Earth, reaching any remaining dinosaurs on the planet. However, the dinosaurs didn't necessarily need to be struck by these glass bullets to meet a fatal end. As the tektites fell, their friction with the atmosphere emitted enough thermal radiation to spark fires across the planet. Some estimates suggest that the combined heat from the returning embers heated the Earth to the equivalent of an oven set to broil. Most of the world's trees succumbed to the flames, potentially explaining why only bird species nesting on the ground survived the impact. Larger land animals that managed to escape extinction typically possessed means of avoiding the intense heat, either through burrowing, as seen in small mammals, snakes, and lizards, or by seeking refuge in water, like crocodiles or turtles. In a stroke of unfortunate luck for the dinosaurs, the Chicxulub impact occurred in an area rich in oil and sulfur. The impact ejected 100 billion tons of vaporized sulfur and 30,000 quadrillion gallons of water into the atmosphere. These elements condensed into massive storm clouds, resulting in torrents of acid rain that acidified the oceans. In higher latitudes, continental-wide snowstorms deposited feet of snow per day. However, the global deluge was short-lived because, in addition to water, Chicxulub vaporized and explosively ejected 150 football stadiums worth of oil from the Yucatan bedrock. This oil condensed in the stratosphere, forming a black sooty layer that covered the Earth like a coat of black paint. Unlike sulfur and wildfire smoke, the carbon from the soot layer circulated high above the cloud layer, preventing it from raining back down. This introduced another significant issue: the soot layer remained in the atmosphere, reducing sunlight reaching Earth's surface by 90% for at least 2 to 3 years. The initial oven-like heat caused by the returning tektites was followed by a prolonged and deep freeze, with global temperatures plummeting by an average of almost 50 degrees. Only tropical islands like Madagascar, India, and Indonesia avoided the deep freeze, experiencing evaporation reductions and rainfall drops of 80%, transforming nearly every spot on Earth outside these islands into a desert. The question of where the giant rock originated arises, and is there another one out there on a collision course with Earth? Researchers, utilizing a supercomputer to study asteroid evolution with data from known asteroids, suggest that the Chicxulub asteroid likely came from the Oort cloud, an outer solar system debris sphere. It might have been a more substantial comet deviated by Jupiter's gravitational field, breaking into several pieces as it approached the Sun. These fragments, capable of crossing Earth's orbit, pose a collision threat every 250 to 730 million years. Based on this study, it's not a question of if another giant rock from outer space could hit Earth, but rather when. In a revelation from December 11, 2021, NASA disclosed that a 330-meter-long asteroid named 4660 Nereus passed Earth at a distance of 3.8 million kilometers, at a speed of 6.5 kilometers per second. While this might not seem close, any slight orbit deviation could potentially bring it on a direct collision course with Earth in the future. Astronomers are monitoring this potentially hazardous rock, anticipating its closest approach to Earth on Valentine's Day in 2060, coming within 1.1 million kilometers. The challenge lies in the fact that we currently lack a known method to defend Earth from a giant space rock. However, NASA's DART mission, Double Asteroid Redirection Test, aims to investigate if a spacecraft can autonomously navigate to a target asteroid, intentionally colliding with it to cause a kinetic impact that could redirect the asteroid away from a collision course with Earth. DART's target is Dimorphos, an asteroid moonlet orbiting a larger asteroid named Didymos, with the spacecraft set to arrive in late September 2022. However, the collision is estimated to change the moonlet's speed by a fraction of 1%. Halting a 10-kilometer wide or larger asteroid hurtling towards the planet at over 72,000 kilometers per second may require more than a small spacecraft impact, perhaps necessitating the use of nuclear weapons, as depicted in the movie Armageddon. If you have an idea on how to stop a world-ending asteroid, share it, and you might become famous. Stay tuned for more exciting updates in our universe. Thanks for watching. We appreciate your support and are delighted to create videos for you.